Hi dear friends and Merry Christmas to you all. In this video we want to talk about the prismatic beam and non-prismatic beams and some criteria regarding them. So beams mainly categorized to two groups: prismatic beams and non-prismatic beams. Beams with uniform cross sections are called to be prismatics, and with non-uniform cross sections are called non-prismatics. So in prismatic beam we have beams with uniform cross section, and in non-prismatic beam we have a beam with a non-uniform cross section with any shape and form. Now let's talk about the different for the consideration for the design of a prismatic and non-prismatic beam. Why we need to have non-prismatic beams. So if you consider a beam, most of the prismatic beam are over designed, and the reason for that is beams of uniform cross sections are designed in such way that the normal stress in their critical sections are smaller than the allowable value of the normal stress. In all other sections, the normal stresses remains below, and mainly much below the allowable stress. That's why most of the prismatic beams are kind of over designed. That's why we need to cut or trim the beam in some parts, and we are using cut off the materials. So that's a kind of saving the money and materials and moving to a non-prismatic beams. In a non-prismatic beam with a varying variable cross-section, as you can see here, the controlling design of a beam is maximum normal stress sigma sub m, and a non-prismatic beam is designed in optimum way when the section modulus S, which is I over C, moment of inertia over the distance to the centroid of every cross section, is satisfying the equation below. S, capital S, section modulus is the amount of moment over the sigma allowable. In such case, for a non-prismatic beam, you can rearrange the equation and jot it down for sigma allowable, which is m over s. And a beam designed in a non-prismatic situation is called a constant strength beam, where the section modulus varies along the length of the beam. You can easily see S is changing because I is changing for this beam, and definitely the moment is changing, but the allowable normal stress remains the same in all over the span. That's why we call non-prismatic beams constant strength beam. Mhm. And in our formula, and that's an important term, in our formula, M, capital M, stands for the moment in the section and in each cross section, and capital S stands for the section modulus. Now, the only thing we have to pay attention that the deflection of non-prismatic beams is a, a, as double of the same prismatic beam with the same materials and the same height. For example, if we have a prismatic beam here, a two simple support concentrated load, we have like delta maximum is equal to PL cubed over 48 EI. But if we want to have the same everything but just non-prismatic beam, we can easily see the the same height, the same everything, the same simple support beam, the same concentrated load at the center, the same height at the center, but this time we cut some part and it moved to non-prismatic, non-uniform cross section. The delta maximum is doubled in this section. That's PL cubed over 24 EI. If you remember for the previous part, that was PL cubed over 48. That's the only consideration we have to be careful about when we work with the non-prismatic beam. Consider the maximum deflection to not be not be higher than the allowable deflection. So if this is a prismatic versus non-prismatic, you can easily see the deflection in a non-prismatic case 2 is as double as the maximum deflection in case 1, which is a prismatic beam. The same story with the cantilever beam in a prismatic and non-prismatic situation. So delta maximum for the top case, which is a prismatic cantilever with a concentrated load that's free and PL cubed over 3EI. For the non-prismatic with the same everything, delta max is doubled of that 2PL cubed over 3EI. And now let's see for which component we can use the prismatic. For a forged or cast structural or machine component, it is possible to vary cross sections over the component along the length and eliminate the most of the unnecessary materials. So that's why we call it, like for a crankshaft or piston rods, you can use it in a prismatic condition or non-prismatic condition. Both of them are applicable in a machine component. Prismatic are useful, non-prismatic is also acceptable. In nickel forged bar, as you can see here, we can have it like prismatic and also non-prismatic. Both are applicable. For a cast steel, also we can use a prismatic variable, non-variable, and also variable cross section in non-prismatic condition. But in rolled steel beam, we can only use prismatic shape. We cannot use the non-prismatic section in a rolled steel beam. And also in timber beam, we can only have a prismatic, and non-prismatic or varying cross section in wood is not allowable. That's all I have for this video. Thank you. I'll see you in other video, and also will provide you with a video which mathematically says why the deflection in a non-prismatic section beam with the same section, with the same material, with the same support is doubled of a prismatic one. Thank you.